Hey guys, welcome back. Consistent Code. So today's problem of the day is Geek and the number string. So what the problem is saying that we're given a string S of size n, which is consisting of letters 0 to 9. So what we need to do in this question that we need to remove the pairs like 1, 2, 2, 1, or 3, 4. So these are the pairs. If we found them, and we can remove them from the string. For example, if we are given the string 1, 2, 2, 1, 3, as it is in the example, so we can see in the start, we can see the pair 1, 2. So we can remove this pair from the string, and then our string will become 2, 1, 3. Now we can again see that we can find a pair 2, 1 again in the string. So we can again remove the string and the string will remain as 3. So this is the minimum string which we can form. So the length of this minimum string is 1 and that will be our output. Similarly, you can check out for this case also when you are given a string 1350. So in this case, you cannot see any pair like this 1, 2, 2, 1 or 3, 4, 4, 3, 5, 6, 6, 5, 7, 8, and all this still here. You will not find any pair, so you cannot remove anything from this. So the minimum length will remain 4 only in this case. So that's it. Now let's see how we can solve any question regarding this. So the algorithm or the data structure which we are going to use for this question will be stack. So let's consider the example which is given so that I can explain it to you more clearly. So suppose what we are going to do, we are just going to start by reading from the string from the starting. We are going to have our stack data structure. So this will be our stack. So what we are going to do now, we are going to check. This will be our algorithm for the complete process for every element in the array or in the string. So now we are at this element 1. So what we are going to do? First, we will check and if stack is empty. So yes, if the stack is empty, we can directly push that element into the stack. So you can directly push this element into the stack. It is pushed while in the stack. So now we will move to the next element, that is 2. Now we will again follow this algorithm. That is the stack empty. So we'll get no, the stack is not empty. So we'll be going to this else part, and now we will check that is the element where this element we are at 2. So is this element odd? So no, the element is even because 2 is even. So we will be moving to this part. So what we are gonna do, we will be checking that if the top of stack is equals to the current element minus 1. So current element is 2 and 2 minus 1 is 1. So is the top of stack equals to this? So yes, they are both equal. So what we can do in that case, we can just pop the element from the stack. So we can remove this element from the stack and move on to the next element. Basically, what we have done so far that we have found a pair of this 1 and 2. Now we move on. So we have removed them from the string. Now we move on to this element 2. So now again we will check using our algorithm and the stack is empty. So we are gonna just push this 2 in the stack. Now we will move to the next element. That is again a 1. So now the stack is not empty, so we'll be moving to the else part. Now in this else part, we are checking if our SI is odd. So our SI, that is this current element 1 is actually odd. So we will be checking that is the top element of our stack equals to uh, the successor of this. So yes, the current element is 1 and the top element of stack is 2, which is the successor. So we are again gonna pop this element from the stack. So we will simply, what we will do, just pop this element from the stack. And when I am popping this element, basically what this means that we have again found a pair of this 2 and 1. So we have removed 2 pairs from the string. And the only pair left, the only element left in the string is this 3. And now I will be iterating to this 3. Now I will again check when the stack is empty. So I will just push this element into the stack. And that will be the end of this algorithm because we have iterated the string completely. So whatever the size of the stack will be now after we have iterated the string will be our answer. Hence our answer will be 1. So I hope you understood the algorithm and now I think we should code it. Although I have already written this sort of code here, but uh, then also let's just code it into that main screen. First of all, we need to have an answer variable that will initially be equals to the length of the string, or that is n, right? So we don't need the answer, sorry. We just need a stack because in the end, the size of stack will be our answer. So let's call this stack and st. What are we gonna do? We are just gonna iterate. We are just gonna iterate over all the elements of the string. And it's the size of the string. So we are iterating over all the elements. And now we are just gonna follow this algorithm for every element. So first case, what we are checking that if our stack is empty, then what are we doing? We're simply pushing the element in the stack. So I can just say st dot push so I while 0. Why am I doing this as if I'm minus 0? Because I have created a stack of integers and my string is having characters. So if I get the difference of the character with 0, I will get the integer value of that character. No. So if the stack is empty, we have simply done what we have done. We have pushed the element in the stack. Now we will go to the else part, and otherwise what we are doing, we are checking if s is odd. So if si and 1, this basically means that as s of I is odd. And in fact, I will say that si minus 0 because si is character. So just we have to do an AND operation. If this, we will be needing an integer. So this value will be an integer. So if this is the case, then what we are doing, we are checking 2 more conditions now. So what is our first condition? That if the stack top is equals to the suffix or I mean the successor of the current element. So if the top element of stack is the equals to 1 plus this f of I minus this 0, 1 plus the current element, then that means we need to pop this element from the stack and that means we have found a pair. Otherwise, what are we gonna do? We're just gonna push. Otherwise, you're just gonna push this current element as of I minus 0, that is the current element to the stack. And what will be the other case? Other case would be if the current element is even. In that case, what we need to do, if the top element of the stack is equals to, as you can see, the previous element, that is, if it was, if it is an even numbers, for example, 2, then we want if the stack top is 1. So we want this number as is I minus 0. That is the current element. This is the current element and minus 1. This should be what we want. So if this is the case, then in that case, we're just gonna pop the element from the stack. Otherwise, as we done previously, we're just gonna push s of I minus 0, that is the correct element, into the stack. So that should be the end of the for loop. And in the end, we just need to return the IO stack. So now let's try compiling and running the code. So we are getting the expected output for the first case. Let's try this for second case also, where we are having string of 4 and the string is 1350. So now let's submit the code and see we are getting all the test cases. So we're getting an error here or 1, 2, 1, and 9, 0. Oh, okay. We forgot about the case when we can also have this 9 and 0. So for that, what we need to do, we need to implement the condition, especially for the case of 0 and 9. So in that case, and the stack should not be empty. And we need to check one thing here, that if the element is odd, so if element that is si minus 0 is actually a 9, then what we need to check, okay, there's one more thing which we can do. We can just take a modulo with 10, right? If the s stack at top is equals to this thing, so if I can just place a mod 10 here, a mod 10 here, and because if this is a 0, then we can just place a plus tab and a mod. Okay, so now why am I placing this mod 10 here? The reason is quite simple. Suppose if this was the case when my current element was odd, and we're discussing about 0 and 9. So if I want the odd number, so that should be 9. 9, if I consider, let's say 9, this is my current element, and let's say that in the top of my stack is 0. But what does this condition check? This checks the number which is greater than 9. It checks for 10. So we will never find 10 in my stack. So what we need to check? A 0. Now can you see that 10 modulo 10 will always be a 0, right? Now similarly, check this thing. When our number is, what are we doing here? If our number is odd here, and so here it should be even. So what should, if this is even, then our current element needs to be 0. Then the top of stack should be 9. Now how to check that? Because when the current element is even, what we were checking, that the current element minus 1 should be equals to the top of stack. But if I check, so this is the case, Yeah. So we are checking that the if the number was odd, and sorry, so we are here when the current element is even, right? So we are at this place. If the current element was even, we were checking for the number less than that number. For 0, that will be a -1, and we want that the top of, if the top of our stack is 9, we want to check that. So to convert this -1 into 10, what we can do, we added 10. As you can see here, we added this 10, and if now you will take a mod 10 minus 1 and just mod it with 10, then that will be 9 modulo 10, and that will give you 9. So basically we just use this modulo operator with 10, so that we can get our answer resolved for 0 and 9 also. And as you can see, if I just run this sample test case, then I'm also getting the correct output now. So now once we have done this, now let's just submit it once again. And you can see we have solved the problem successfully. I hope you liked the explanation, and if you did so, make sure you hit the like button and subscribe to the channel, and I will be seeing you tomorrow with the next problem of the day. Until then, still, bye bye.